Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox where I teach you how to become a middle school math master. So if you're interested in that, hit the subscribe button down below. Today, we are talking about the laws of exponents and some of the different fun things that you can do with exponents when you've got certain situations. Specifically, we're going to be talking today about product of powers, quotient of powers, and power of powers rules. All right, so let's just go ahead and get right into this. And we're going to see this first example. This is going to be the product of powers rule. And before I give you the rule, I want to see if we can make some discoveries on our own to help us, when we learn the rule, kind of solidify the rules into our brains. So we have a situation right here where we have two exponents multiplied by each other. And I notice that each exponent has the same base, 2. All right, we've got 2 to the power of 4 times 2 to the power of 3. All right, this is the product of powers rule. Whenever I'm multiplying exponents with the same base, I'm going to do something with the exponents. But first, I'm going to show you what to do if all else fails. If you forget this rule, all right, and your test question says, use the product of powers rule to simplify the expression. But you get to the point where you're like, I don't even remember what the product of powers rule is, all right? This is what you can do. The first thing you can do is write your expression in expanded form, all right? You'll notice here that I took 2 to the power of 4 right here, and I represented it in expanded form, all right? 2 to the power of 4 is kind of a grouping in and of itself, and so I represented it as 2 times 2 times 2 times 2, all right? There's 4 2's right there. That's 2 to the power of 4. Then I kept the multiplication sign in between them, all right? And then I represented 2 to the power of 3 in expanded form, 2 times 2 times 2, all right? And now I notice I have a whole bunch of numbers that are being repetitively multiplied, all right? The number 2 is being repetitively multiplied, which I know is exponents. Exponents is repetitive multiplication, all right? So in this case right here, I have just multiplication between all the numbers, all right? Which means I can apply the associate property of multiplication rule, which means if I'm multiplying numbers, I can group them any way that I'd like to in order to be able to multiply them, which essentially means I can drop the parentheses in this case. Because it's all multiplication all the way through, ultimately, I'm just going to have to multiply all the numbers, all right? Well, this is 2 times 2 times 2 times 2 and so on. It's repetitively multiplied, which I know is exponents. So I can represent that as 2 to the power of 7, all right? Now go back and look at the original problem. 2 to the power of 4 times 2 to the power of 3. And see if you can make the connection in your own mind, all right, for how that's the same as 2 to the power of 7, all right? Hopefully you said that you can add the powers, all right? Here's the rule. To multiply two exponents with the same base, that is key, all right? It has to be the same base. If it's not the same base, you cannot apply this rule, all right? To multiply two exponents with the same base, you keep the base and you're going to add the exponents or add the powers, all right? So in this case right here, 2 to the power of 4 times 2 to the power of 3 is really 2 to the power of 4 plus 3, which is 2 to the power of 7, which ultimately is 128 when you do all the math multiplied out, all right? So that's the product of powers rule. To multiply two exponents with the same base, you keep the base and you add the exponents. So now I want you to try one, all right? So if you're new to this channel, what I try to do is give you opportunities to try problems. So go ahead and try this one. You can pause the video. You can try it at home or wherever else you are, and then you can come back to see if you got the right answer. So now I expect you to pause it, okay? Come back when you got the right answer. All right, so I'm assuming you've done this already. We've got 4 to the power of 5 times 4 to the power of 3's. I can represent that two different ways, all right? Either I can write it in an expanded form, which this 4 to the power of 5 is 1, 2, 3, 4, 5 4's, times 4 to the power of 3, which is 3 4's, and I can do it that way. And then just count up how many 4's I have. Or I could apply the product of powers rule, and I could do 4 to the power of 5 times 4 to the power of 3 is really 4 to the power of 5 plus 3, which is 4 to the power of 8. And that answer is 65,536. All right? Try this one. All right? Pause the video, try it, come back and see what the answer is. Okay, this one here, you've got 3 to the power of 3 times 3 to the power of 6, which is 3 to the power of 3 plus 6, which is 3 to the power of 9, which is 19,683, all right? If you didn't remember the product of powers rule, you can simply write out all your exponents in expanded form, add them up, call it a day, all right? That's the product of powers rule. So when you're multiplying exponents with the same base, you add the powers and you keep that base, all right? Let's move on to the quotient of powers rule, which it goes to reason that if we're multiplying exponents at the same base, we add the exponents. If we're dividing exponents at the same base, we're going to subtract the exponents. That's the connection I'm thinking is going to be, and we're going to kind of see how that plays out here shortly. But first, I want to show just a simple problem right here, all right? This is going to help us when we do the expanded form, all right? If I have these fractions multiplied out, notice I've got 1/2 times 2/3 times 3/4 times 4/5 times 5/6 times 6/7 times 7/8, right? Traditionally, I can multiply all the numbers across the top and get 5,040, and I can multiply all the numbers across the bottom. I get 40,320, which simplifies to 1/8, all right? If I did all the simplification out, divided it by common factors, ultimately I'd get down to 1/8 as the simplest fraction, all right? There's another way to do this though, and it's a little bit more simple, all right? You've got these fractions multiplied again times each other. Whenever you're multiplying fractions, or whenever you have a fraction and all your multiplications in the numerator and all your multiplications in the denominator, if you see the same number in the numerator that's also in the denominator, they cancel each other out. Notice that 2 canceled out that 2, and the 3 canceled out the 3, and 4 canceled out the 4, and 5 canceled out the 5, and 6 canceled out the 6, and that 7 canceled out that 7. So all we have left over is 1 on the top and 8 on the bottom. That's a little bit faster than doing all the multiplication and then all the simplification after that. So just understand that you can do that in math, and it helps make your life a little bit easier, all right? That if you're multiplying fractions and it only works with multiplication, you can't do it with if you have addition or subtraction or anything else, all right? If you've just got multiplication of fractions and you see a number that's in the numerator that's in the denominator of a different fraction, they can cancel each other out, all right? So keeping that in mind, let's go on to the quotient of powers rule, all right? Just like with the product of powers rule, if all else fails, you should represent your expression in expanded form. So right here I have 3 to the power of 6 divided by 3 to the power of 2. I can represent that in expanded form like this. On the top, the numerator, I've got 6 3's multiplied by each other. And in the denominator, I have 2 3's multiplied by each other, all right? So notice I've got all these 3's on tops and these 3's on bottoms. If I just remembered the little trick that I talked about just a moment ago, that if I see a number on top that's also on bottom, it can cancel each other out. So these 2 3's on bottom cancel out 2 3's on top. Now don't forget that once we cancel these out on bottom, the leftover is 1, all right? It's not 0, all right? This is 3 times 3 times 1 times 1 times 1 times 1 times 1. There's an infinite number of 1's, all right? So we don't represent those because they are just, it doesn't change the problem at all. And so it's unnecessary to represent all the multiplied by 1's that's on the bottom. But this is 3 times 3 times 1. All right, and so when I cancel out the 2 3's on bottom, I have a 1 on bottom, and I've got 4 3's on top, which is 3 to the power 4 divided by 1, which is just 3 to the power 4. That sounded a little confusing, but essentially, if you got a number on top, it cancels out on bottom, and then the leftover is a 1 on the bottom. Take the numerator divided by 1, you just have the numerator, which is 3 to the power of 4, which is 3 times 3 times 3 times 3, which is 81. All right? So the quotient of power rule says that if you're dividing two exponents with the same base, you keep the base and you subtract the powers, all right? So 3 to the power of 6 divided by 3 to the power of 2 is really 3 to the power of 6 minus 2, which is 3 to the power of 4, which is 81, right? That's the quotient of powers rule. Dividing exponents with the same base, keep the base, subtract the exponents. So you try this one. You've got 4/8 divided by 4 to the power of 8 divided by 4 to the power of 5. So I see here that I'm dividing an exponent, dividing exponents with the same base. I'm going to do something with it. I want you to try this. Pause the video, try it, and then come back to see what the answer is. All right, in this case right here, I could do this one of two ways. Either I could write the expression out in expanded form and cancel out my 4's, or I could apply the quotient of powers rule, which is 4 to the power of 8 divided by 4 to the power of 5 is 4 to the power of 8 minus 5, which is 4 to the power of 3, which is 64. All right? Notice the 8 minus the 5 there gives us 3, and then we apply 4 to the power of 3, we get 64. All right, try this one. All right, pause the video, try it, see if you understand it. All right, this is 5 to the power of 6 divided by 5 to the power of 2, which is 5 to the power of 6 minus 2, using the quotient of powers rule, which is 5 to the power of 4, and that's 625. All right? So the quotient of powers rule says when you're dividing exponents with the same base, keep the base, subtract the exponents. The last one is the power of powers rule. All right? The power of powers rule exists when you're raising a power to another power. All right? Like in this case right here. I have 2 to the power of 3 risen to the power of 2. All right? So I've got 2 to the power of 3 to the power of 2. This power of 2 on the outside, we've got to do that exponent first, is really just what's on the inside, 2 to the power of 3 multiplied by itself, all right? Because exponents, remember, is repetitive multiplication. So this 2 on the outside tells me that I'm going to represent the inside 2 times. And then when I write that in expanded form, that's 2 times 2 times 2 times 2 times 2 times 2, all right? Which in this case is 2 to the power of 6, which is 64. So let's see if we can make the connection here. See if you can make the connection between 2 to the power of 3 to the power of 2 and 2 to the power of 6. Hopefully you see that we multiplied the powers. The product of powers rule says the power of powers rule says, and these get kind of confusing to say them all at the same time. So that's why I'm showing you that if all else fails and you forget these rules, you can write them in expanded form and it's going to help you complete the problem, all right? But the power of powers rule says to raise a power to a power, you need to multiply the exponents, all right? And you keep the base. So 2 to the power of 3 to the power of 2 is really 2 to the power of 6. All right, why don't you try this one right here? 3 to the power of 4 to the power of 2. Pause the video, see what you get. All right, 3 to the power of 4 to the power of 2 is really 3 to the power of 4 times 3 to the power of 4, which is 3 times 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 3, which is 3 to the power of 8, and that's 6,561. All right, one more problem, and then we're done. All right, 4 to the power of 3 to the power of 3. Pause the video, try it, see if you can get the right answer. All right, 4 to the power of 3 is really 4 to the power of 3 times 4 to the power of 3 times 4 to the power of 3. When I write it in expanded form, it looks like this. And I add them all up, I've got 9 4s, all right, which is 4 to the power of 9. Or I could have done back here with the power of powers rule, when I'm raising a power to a power, I keep the base and I multiply the exponents. 3 times 3 is 9. And then 4 to the power of 9 is 262,144. All right, that concludes our lesson today. Really didn't have to do a whole lot on the board. I should have probably just had the PowerPoint up, but no worries, no harm. I hope you have a great day, and we'll see you next time.